Okay, so good afternoon, everyone. Happy to be here today to share a story behind the creation of our test RC car, from the initial idea to the challenge we faced along the way. A little bit about me. I'm a full-stack developer, system administrator, but we don't care. What really brings me here is my passion for building things. So about the OVCS project. So with my two associates, Mark and Thibaut, we spent 6 years building open banking regulator in Elixir and wanted to push a bit the boundaries and try Elixir in the automotive world. So in 2024, we created the Open Vehicle Control System, which is an Elixir-based development kit for vehicle enhancement. So with OVCS, we want to allow vehicle modernization, like including electric vehicle conversion, infotainment enhancements, or advanced feature like a remote control or autonomous driving. So the OVCS project started with a VW Polo of 2007, but testing features like a remote control or autonomous driving with a 1-ton vehicle on a public road was a bit too risky. So we decided to scale a bit down and build an RC car with the similar components that provide a much safer way for testing. Those are the steps toward the build of our rocket RC car. So we went for a Traxxas /4x4. Traxxas is a well-known brand, so if you can find parts to repair it or tune it if you want to, plus this one can reach the 100 kilometers per hour. Then we had to design some CAD file for 3D printing. We want all those components to fit perfectly. We want to swap them easily and replace them if needed. We also had to manufacture some PCBs, like Arduino, Raspberry Pi hats. We also built KNFD modules to fit the parts in the small area. And then the assembly, wiring, because there are a lot of wiring, and integrate everything inside the VW Cox body. So those are the components actually present in this RC car. We have a wall-snail AGF-PV with one camera, an express RS radio receiver. Those two come from the drone worlds, for those who know. We have an IMU. We have 2 more cameras for stereoscopic vision. And then we have all the components for OVCS. We have the core, which is called Vehicle Management System. Then we have bridges that making the link between OVCS and ROS2, for example. Then the link between Mavlink and also OVCS. Mavlink is the protocol we use to communicate with the radio receiver. And then the MSP OSD also to display useful things inside the FPV system. All those components are running on a separate Raspberry Pi using Elixir and nerves. We also have an Arduino with, as we call it, a generic controller, which is making the link between OVCS and a component at a lower level, like generating PWM for steering or the throttle of the Traxxas. We also built some custom 5-volt PSU to convert the battery to 5-volt for the components, multiple KNFD controller on SPI, because all those components communicate as the full-scale car using CAN bus. And we also have a switch and a Wi-Fi hotspot. There is no more space, as you can see. You have the switch on the front, you have the 3 cameras also, the FPV system, a hat, 2 Raspberry Pi, and there's again 2 Raspberry Pi on the other side, and Arduino. But nice, so that's cool. So what we learned along the way, we wanted to make a composable code architecture, because in OVCS you have the V. V stands for vehicle. So we wanted to find a way for the user to customize their vehicle to fit their needs at best. Miniaturization challenge, yes, because using the same component in a full-scale car into a 110 RC car was a bit complicated, so it was difficult to put all the parts together. We wanted to keep it clean because our goal is to make something simple and accessible so that you can try it at home if you want to. Next step, we'll finalize autonomous part with ROS2, test it at high speed, and much more, because there is so much thing that we can do with the platform that there's no real limits. So thank you for listening. Everything will be available on the vcs.be. If you want more detail, we have a talk at 4 p.m. today also. And please reach me if you want to try at home, if you want to tinker with us. There is my email. Thank you.